Chapter 8 Hydroxy Compounds. 8.4 Chemical Properties of Alcohols. At the end of this topic, students should be able to A. Explain the reaction of alcohol with reference to 1. Reaction with sodium, 2. Esterification, 3. Dehydration, 4. Substitution reaction using hydrogen halide, phosphorus trihalide, phosphorus pentachloride, or thionyl chloride, SOCl2. Reaction of alcohols involve two types of bond cleavage. The first one is between CO breaking the bond with H bond cleavage. Second, C clef of OH bond cleavage. For the number 1, COH bond cleavage, the alcohol acts as a weak acid, which is act as proton donor. Thus, ROH treated with water produce RO- and H3O+. For second one, COH bond cleavage, alcohol acts as a basis, proton acceptor. ROH react with HA, produce Ra and water. Reaction with sodium. In an aqueous solution, alcohol reacts as a very weak acid. ROH treated with Na in the room temperature produce RO- and A+, alkoxide salt, and release half mole of H2. The example is ethanol treated with Na in the room temperature produce sodium ethoxide and half mole of H2. This shows the acidic properties of alcohol. Write a balanced equation for the reaction of cyclohexanol with sodium metal. As you can see, cyclohexanol treated with Na produce sodium cycloethanoate and release half mole of H2. Esterification. Alcohol reacts with carboxylic acid under reflux and is catalyzed by mineral acid, for example, sulfuric acid or HCl to produce an ester. Alcohol plus carboxylic acid, reflux H plus reversible reaction produce an ester and water. The product of an ester showing that R1 is come from the alcohol while R2 is come from the carboxylic acid. Another example, example 1, methanol treated with ethanoic acid, H plus heat under reflux, reversible arrow, produce methyl ethanoate and water. Second example, ethanol and 2-methyl propanoic acid. In a reflux, H plus acid mineral catalyzed and reversible arrow to produce ethyl 2-methyl propanoate. The third example is cyclohexyl methanol treated with 2-methyl propanoic acid in the presence of acid catalyzed reflux, and that is the reversible reaction produce cyclohexyl 2-methyl propanoate and water. Third, dehydration. Dehydration involves the reaction of alcohol and concentrated sulfuric acid heat at 170 degrees Celsius to produce the alkene and water. Another example is 2-butanol treated with concentrated sulfuric acid produce 2-butene and 1-butene and water. So there are two products, major and minor product. And to determine the major and minor, so this reaction applying the rules of Side-Zepf that you already learned in the alkenes. Substitution reaction. Alcohol undergoes substitution reaction with haloalkene HX, phosphorus tri or pentahalides PX3 or PCl5, sulfur dichloride oxide SOCl2, and conversion of alcohol to haloalkanes involving X-use selective such as Cl or Br. Substitution reaction. ROH treated with HX to produce RX plus H2O. For example, 2-methyl-2-propanol treated with HCl in zinc chloride produce 2-methyl-2-chloro-2-methylpropene and H2O. Heating with concentrated HCl in the presence of hydrogen chloride as catalyst. Order of alcohol reactivity is tertiary, greater than secondary, greater than primary. And order of HX reactivity is HI is greater than HB, R and greater than HCl. Haloalkene HX. The mixture of concentrated HCl and zinc chloride is called the Lucas region. The formation of the alkyl chloride causes the mixture to be cloudy. Tertiary become cloudy immediately. Secondary become cloudy within 5 to 10 minutes. And primary non-observable changes within 5 to 10 minutes even after heating. Phosphorus tri or pentahalides PX3 or PCl5. Alcohol react with PX3, PCl5, SOCl2 to form RX haloalkene. The equation is 3 mole of alcohol react with PX3 produce 3RX plus phosphoric acid H3PO3. ROH treated with PCl5 produce RCl plus POCl3 plus HCl. For example, 3 mole of ethanol treated with PCl3 in reflux produce 3 mole of chloroethene and H3PO3. And another one is ethanol treated with PCl5 produce chloroethene and POCl3 plus HCl. Substitution reaction. Sulfur dichloride oxide SOCl2 ROH reacts with PX3, PX5, SOCl2 to form RX. Equation involved is ROH plus SOCl2 produce RCl plus SO2 and HCl. The example given is ethanol treated with SOCl2 to produce chloroethene and SO2 plus HCl. That's all. Thank you.